Hello, Algebra 2 students. Today we're going to look at Skill 4, which will be about composition of functions. All right, so we did function operations in the last class, and we're going to start by just reviewing how to work with just plugging in something into a function. And then we'll talk about what it means to plug a function into another function. All right, so the way we do this is we replace the outside function variables with the inside functions. Okay, and that'll make sense when we talk about this in a moment. So if I look at just doing g of 3, well, I know I've got to look at my g of x formula, and I'm replacing the variables in that formula with whatever's inside. Okay, so in this case, it would just be 4 times 3 minus 1, which makes 11. Excuse me. Now, if I were asked to do g of 2x, that means I'm replacing, still using the g of x function, but I'm replacing the x with 2x. So it'll be 4 times 2x minus 1. And so you'll notice when we evaluate this one, we do not get a numeric answer. And if I replace the x in the g of x function with 2x minus 5, I would have 4 times the quantity 2x, or not minus 5, but plus 5 minus 1. So we distribute here, we get 8x plus 20 minus 1, which results in 8x plus 19. Okay, so that's how we're going to just replace a function with something. So if that's all it means to do, evaluating a function, then doing a composition should be no big deal either. I think what students get tripped up in is the notation more so than the actual procedure. So this is g of f of x, okay? So that means that my f of x function, which I'm going to underline in red, f of x is defined as 2x plus 5, okay? Whoops. Sorry about that. And what we're doing is we're putting that 2x plus 5, we're putting that into the variable for the g of x. So it basically becomes g of 2x plus 5. Sorry, I wrote that really sloppy. And I'm making it worse. So if you identify what f of x is just this function 2x plus 5. All we're doing is we're plugging in 2x plus 5 into the variable for g of x. And we just did what that is. So that gives us, by example C, g of f of x equals 8x plus 19. Okay? Now, if I do f, this says what is f of g of x? So this time we take our g of x function, which is 4x minus 1, and we're going to plug it into the variable for our f function. So that means we're really finding f of 4x minus 1, which means we're going to plug in 4x minus 1 for the x on f of x. Okay, and when we distribute, we get 8x minus 2 plus 5, which gives us 8x plus 3. Okay, excuse me. Now, for f of x, this one's probably the weirdest because the notation is even still different. So we know f of x is our inside, so we're going to take this f of x, this 2x plus 5, and we're going to replace the variables of f of x. So it's like we're putting this function inside of it. It's like nesting dolls, if you think about it. So what we're doing is we're really finding f of 2x plus 5. Well, when I replace the x of the f of x function with 2x plus 5, it'll look like this. Distributing, we get 4x plus 10 plus 5, which gives us 4x plus 15. Okay? All right, the next part asks us to find f of g of 2, and there's two ways to do this. Way one is to plug in 2 for the g function, and so that'd be 4 times 2 minus 1, which we did that a moment ago. No, we didn't. Sorry, that was 2x. So we get 7. So that would be our first step. And then our second step would be to find f of that value, which is 7. So we use our f of x function, so 2 times 7 plus 5. And we get 19. So this method is just plugging in the 2 ahead of time. That way it kind of makes your life a little simpler. But we could have first figured out what f of g of x is first. And we know what f of g of x is because we did that in letter f. So by example f, we get f of g of x equals 8x plus 3. So that would be our first step to find what f of g of x is, and then step 2 would be plug in 2 for x. So now we know what f of g of x is, so now we can find f of g of 2 by taking 8 times 2 plus 3, which is 16 plus 3, and we get 19. Okay, so that way we still get the same value. So that's just how we can evaluate numerical compositions. We're going to do some more practice with just finding composition functions, and then we will look and see how we do it from tables and graphs. Okay? All right, let me change colors here. So, example 2, you'll notice here I have a quadratic and a linear. So if I want to find f of, if you see this notation f circle g, that means you're just finding f of g of x. So we're taking g of x, and we're going to substitute that in for the variables of f of x. So we have to make it a substitution twice. Excuse me. So we have 2 times the quantity 3x plus 2 squared minus 3 times the quantity 3x plus 2. All right, so sorry. When I do this, I have a square first. So what I need to do is I need to multiply 3x plus 2 times itself. And when I look at that, hopefully we know how to multiply out 3x plus 2 times 3x plus 2. If not, I will remind us really quickly over here. 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. And 2 times 2 is 4. 6x plus 6x, we get 12x. So we're going to end up with 9x squared plus 12x plus 4. And as you can see, I'm running low on room, so I'm going to erase what I did here. Keep in mind, if this video is going fast, you can always pause, rewind, and etc. Doing my distributive property on both groups, I get 18x squared plus 24x plus 8, and then minus 9x minus 6. So when I simplify that, I get 18x squared. So 24 minus 9 is 15x. 8 minus 6 is 2. Okay, and you might be thinking, oops, I no longer like this. Well, keep in mind that that was probably a little more on the challenging side of things. The good news is if we went the other way, finding g circle f, which means we plug in f of x into our g of x function, this is a little bit nicer because we're taking that quadratic part and we're plugging it into just one variable and it's all linear. So when we do this, we're going to have 3 times the quantity 2x squared minus 3x plus 2. Notice here we don't have any squares on our groupings, so we can just go ahead and distribute 6x squared minus 9x plus 2. No like terms, so that is all we do. So not all the time when you have compositions, not all the time will you have them be terrible. All right, we're going to look at example 3, and I want you to make special note of what happens here. First of all, notice that f composed with g versus g composed with f did not result in the same thing. Notice that these are different. Sometimes they might. And in these examples, we are going to see how that works. All right. F of g of x. So f of x is 7x squared plus 5. G of x is this stuff. We're finding f g of x, so we're plugging in our g into our x for the f of x function. Sorry. And this is what we start with. Now, first thing I notice immediately is I'm squaring a square root, so those cancel out. The next thing I notice is that I'm taking a 7 and multiplying it by something that was divided by 7, so those cancel out. So I get x minus 5 plus 5. And then we have minus 5 plus 5. Those also cancel out. So this just ended up equaling x. Interesting. Now, if I reverse this and I go g of f of x, that means I'm plugging in this f of x into the variable for g of x. So that means I would be doing the square root of 7x squared plus 5 minus 5 over 7. And looking at this, what I'm going to first notice is that my plus 5 and my minus 5 will cancel, so that gives me the square root of 7x squared over 7. The 7's will cancel, so I just end up with the square root of x squared. And we know that squares and square roots cancel, so this just equals x as well. Excuse me. You'll notice that in this example, we ended up with the same thing when we did both compositions. We'll explore this in more detail in the next lesson, but when you see something like this, that means that one function is the inverse of another. Okay, so these two functions up here are inverses. They're functions that undo each other. But we'll explore that idea in the next lesson in more detail. All right, last thing I want to show you is how to use tables to find compositions, and then how to use graphs to find compositions. All right, looking at this table, this top table tells us an f of x function. We see the f of x right here. The top row is the inputs, and the bottom row is the respective outputs. The next function down here is our g of x function. So here's our function. Again, the inputs are on the top, outputs are on the bottom. And we want to come up with the values for f of g of x, or sorry, g of f of x. Okay? So we're taking our f of x values, so these values up here. And what we're going to do is we're going to plug them into our, well, actually, I said that backwards. We want these values, because these are the f of x values. We're going to plug those in to our g of x. All right, so looking at this, if I want to find g of f of 1, so I'm looking at this 1. What I'm going to do first is look at f of 1. So here's the input 1, and we get an output of 2. So I have to put that output of 2 as the input for g of x. So notice that we're going to go to here. And when I plug that in, I get negative 3. So if I finish following the chain, f of g of 1 would be negative 3. I'm going to use a different color to illustrate the next one. If I were to do f of g of 2, Well, here's my here's my 2. F of 2 gives me -1. So I look for that input in the g of x function, and the result is 0. So that becomes my g of f of 2. A lot of times when I'm teaching this to my students, I just tell them to follow the chain. So we start, if I want to find g of f of 3, I start with my f input of 3. That gives me an output of 5. So now I'm going to look for that output of, or that 5 as an input for g of x, which gives me 1. So that means that g of f of 3 is 1. And just to continue on, if I do g of f of 4, f of 4 is 7, so now I'm looking for 7 as the input for g. G of 7 is 5, so that means that g of f of 4 is 5. On the next one, to find g of f of 5, we look for the input of 5 on the f function. That gives me 19. When I use that as an input for g of 19 is 12. So that means g of f of 5 is 12. And hopefully by now you kind of get where this is going. So I'll just do this last one pretty quickly. So f of 6 is 4. G of 4 is also 4. So g of f of 6 is 4. Okay? Alright, so that's how that's going to work. Now let's do the same thing from a graph perspective, okay? So I give you 2 graphs, one is f of x and one is g of x, and what we're going to do is we're going to find different values. So the first one says, what is f of g of 1? So first we're going to find g of 1, so we look at our g of x function. G of 1 is 2. So now what we do is we go over to our f of x function and look up f of 2. F of 2 has a value of 0. So f of g of 1 equals 0. We'll do a different color here. If I do g of f of 1, I look up f of 1. F of 1 is -2. So now I go to the g function and look up g for -2, which gives me -1. So g of f of 1 is -1. For the next one, I am going to be doing a composition where we put a function inside of itself. So f of 3. So first I find f of 3. So I go to my f of x function. F of 3 is -1. Now staying on that same function, f of -1 is 2. So f of 3 is equal to 2. Okay. All right, I'll do a couple more quick examples here, a little bit quicker. We'll certainly discuss these tomorrow as well. Or I guess it's not tomorrow, depending on when you're watching this. We'll discuss these next class. All right, f of g of -3. So first I look at g, and I look for -3, and that gives me a value of -2. So now I'm to find f of -2. So now I'm going to go over to -2, and I get a value of 1. So f of g of -3 is 1. For the next one, I am finding f of -1 first. F of -1 is 2. So then I go to my g function and find g of 2, which is also 2. Okay. And then the last one, I'm going to do g of 0. So g of 0, go to 0, and we get 1. So then I find g of 1, which is 2. So g of 0 is 2. And that is how we do compositions with graphs. So we'll now have a chance to do some practice with it.